Hello everyone, we are Team AiCell and we are on a mission to revolutionize AI accessibility in Bangladesh. I am Abu Bakr Siddiq Imon, leading the AI backend integration where I connect intelligent language model with our local server to make AI communication possible through SMS. Alongside me, Abir Kumar Shanto handles the hardware and system integration, linking the ESP32 GSM module and laptop server to ensure smooth message transmission between users and our AI system. Nafisa Nawal Trina is responsible for documentation and content preparation, while Sajid Ahmed Rahi manages the research, presentation slides, and supporting documentation. Together, we combine expertise in IoT system, GSM, communication, and artificial intelligence, working together on one goal to bridge the digital divide through simple, inclusive, and accessible AI technology for everyone. Problem statement. In Bangladesh, more than 95% of people own mobile phones, yet nearly 40% still lack internet access, creating a serious digital divide. Rural communities, elder citizens, and low-income families often cannot access AI-powered tools or online information because most services require smartphones and stable internet connections. During disasters like flood, cyclone, or power outage, this problem becomes even more critical. Cut off millions from essential healthcare guidance, agricultural support, and educational resources. This is not just a technology gap, it's a human problem. People need immediate and intelligent help, even when they are offline. That's why we built AiCell, an innovative system that brings AI power assistant directly through SMS, allowing anyone, anywhere to communicate with AI using just a simple mobile phone SMS without the need for internet access. Now, Abhi Kumar Shanto discuss the solution of our AiCell.
So now let me explain our solution. AiCell is an AI-powered SMS hotline designed for people who don't have smartphones or internet access. Users can send a simple SMS from any basic phone and instantly receive AI-generated replies or responses through the same SMS channel. It supports both Bangla and English, ensuring everyone, even in rural or remote areas, can easily access AI-based help. AiCell mainly targets healthcare, agriculture, and education, where quick access to reliable information can make a real difference. So here is how our AiCell system works behind the scenes. When a user sends a SMS, it is first received by the SIM800C GSM module. Then, the ESP32 microcontroller collects the message and sends it to our Flask-based Python server. The server processes the text using either local database or connects to an AI engine or for smart replies. After generating the response, the message is sent back from the server to the ESP32, which passes it through SIM800C module to the user's phone, completing a full offline capable AI interaction. The hybrid setup makes AiCell fast, reliable, accessible, and even without the internet. So that the diagram shows our SMS processing workflow. So first of all, user sends an SMS, it's received by the SIM800C, then the ESP32 forwards it to the Flask server, and the server first checks and then sends the reply in the same path. So we are using some hardware components like ESP32 for handling Wi-Fi and communications between GSM and server, and SIM800 GSM module for sending and receiving SMS, and laptop servers for running our Python Flask backend and AI or FAQ engines. And we are also can use Arduino for testing SMS communication and power supply, and 5-volt power supply is needed for ESP32 and SIM800C. So our server and software. So we are using Python Flask-based backend server and local database for instant replies, OpenAI API for fallback AI response. And we are using ESP32 for forwarding message to server via Wi-Fi, sending SMS back when through SIM800C, and verifying SIM800C sending and receiving functionality. So now my teammate Trina will continue.
Now let me explain how AiCell works. AiCell works in a simple way. When a user sends an SMS, the SIM800C module receives it and passes it to the ESP32, which forwards it to our Flask server. The server checks if it's a command like #help or #info. If so, it replies instantly. Commands like #connect or #mode change the AI mode such as health or education. If it's not a command, the server connects to OpenAI to create a smart reply. The response goes back through the ESP32 and SIM800C to the user, all in about 30 seconds. So AiCell lets you chat with an AI using only SMS, no internet needed. This slide shows the command system and AI modes of AiCell. Users can send simple SMS commands like #help to see all commands, #info to learn about AiCell, and #connect to activate AI mode. They can also switch between #mode, health, AGRI, or EDU for different types of assistance. AiCell has three main modes: healthcare for medical tips, AgriCell for farming advice, and EduCell for learning support, all through easy text messages. Now my groupmate Sajid Ahmed Rahi will continue the rest of the presentation.
At this point, a question may arise on your mind that why to use AiCell? Well, we have defined some of the reasons here, as you can see. The first reason is it works with any basic mobile phone, not just smartphones, it works with the button phones as well. Offline, ready and cost effective. You don't need any internet connection for this service. Then first reply via SMS within 30 seconds. We are going to ensure that. Supports Bangla and English. Focused assistance, health, agriculture, education. Promotes digital inclusion and AI accessibility. Let's take a look at a sample message style. A user needs help about his health condition. At first, he needs to type #help. After that, the AiCell will ask him what kind of help he needs. Then the user needs to type the mode. In this case, the mode is health. And after that, the healthcare mode will be activated. And the AiCell will ask the user for further health questions. Now that we have come a long way, our project has not reached its peak yet. Here we have highlighted some points that we are going to add and upgrade our project. First of all, we are going to add offline Bangla knowledge base expansion. Obviously, this project is designed for rural area peoples, so they normally don't know English that much. Multi-user AI memory and session tracking, web dashboard for message analytics, IoT emergency alert integration, potential low-cost device kits for rural deployment. These are some improvements and future enhancements that we are going to do. The author of this project is Abu Bakr Siddiq Imon, a student of Department of Internet of Things and Robotics Engineering, University of Frontier Technology, Bangladesh. Here we have provided the GitHub username, which is ABS Imon, and our email address, iotandrobotics@gmail.com. Thank you.